For this question, they want us to identify any intercepts and test for symmetry, and we have an equation there that's a bit complicated to initially solve for x-intercepts or y-intercepts. It's algebraically possible, but I would like to encourage us to use graphing calculators at this point. If you have a graphing calculator that you own, you may use it. If you do not have one, you can use the internet, and I'm going to show you how. If we go over to the internet and just search for graphing calculator, it brings it right up. The first option is actually a wonderful calculator for doing graphing. So our function was x squared minus 2x. And if you see, we very quickly get the picture of that graph. And so the questions that were asked were, what are the x-intercepts? There are two of them. We need a smaller x value and a larger x value. And then what was the y-intercept? Well, we can clearly get this information off of our picture. So our x-intercepts, we cross the x-axis. Again, that's what an x-intercept is at 0, 0. And we cross the x-axis at 2, 0. So those are our two x-intercepts. And our y-intercept is actually the same as our x-intercept, because in this unique equation we actually go through the origin. So one of our x-axis intercepts is a y-intercept as well. So for this question, we would go and type in this box here. Notice they've already given us the parentheses for the ordered pair. We don't need to type parentheses. We just need to type, the smaller one was the 0, 0. The larger x value was where we went through 2, 0. And as we mentioned earlier, our x-intercept and our y-intercept are the same thing at 0, 0. Now let's go back and determine if we have any symmetry. Now this gets a little bit tricky. This function is very symmetric. When you go through x equals 1 here, it's obviously symmetric on both sides, but when we determine symmetry, it needs to be symmetric about the axis, either x or y axis, or the origin. And so remember, whatever is on this side of the y axis needs to be identical, a mirror image of what's on this side. We don't have that. And of course, you very clearly don't have x-axis symmetry, because what's on this side is not a mirror image of what's on this side over here. And origin symmetry, it says whatever is in this quadrant is a double mirror image of what's in this quadrant, and we don't have that. So in this case, we would say there is no symmetry. And again, the function is symmetric to itself, but it's not symmetric. Not there. We would check no symmetry.